This is AP Calculus 6-9 Part 4, Integration of Transcendental Functions. We did derivatives of transcendental functions earlier in the year. These are just formulas you have to memorize. Basically, there's only one more. We've already done natural log. That's where you take, if you have the natural log of something and you take its derivative, you have the derivative over the original. This is a transcendental function with a base number something other than x. So like you might have the integral of 5 to the x, or you might have the integral of 10 to the 3x power. And you have to know how to integrate those. And again, it's just a formula. So a will be a number, and then x is your function, or u is your function with a variable within it. And the variable can be anything. Most of the time it'll be x or t, but these are basically the same thing. This one just has an x here for your u part, and here we have a u, and we understand that the derivative of u is your du, okay? So we're just gonna, the easiest way to do this is to just do a couple examples and see how the formulas work, because it really is just plugging in, recognizing what you have, and plugging into a formula. So if I give you the first one, so for this one, we have the integral of 2 to the x dx. Well, if you look at this function here, x is our u part, right? So the derivative of that u part would just be 1, so it's not going to affect anything here. So to take the antiderivative of this, or the integral of that, we're going to put 1 over the natural log of the base part, 2, and then we're going to multiply that by the original function, a to the x or 2 to the x. Since that was an indefinite integral, don't forget your plus c. Another one, what if we don't have an x here? What if we have some form of x there? So what if I have something like this? Here I have a 5 to a power. So we've got the base number to a power that is an expression involving a variable. So I would say that this is probably one like this, but the difference is it's got this extra x tagged along here. And we'll see if we can take care of that by naming the u and the du and see how that affects our problem. So if we think about this one, I'm going to let u, and I will always let u equal the exponent part. So u here is negative x squared. So that means my du is going to be negative 2x dx. So if we're doing our u substitution and just thinking about what we have here and how we can substitute in, I've got 5 to the u, and then I've got x dx, but I'm missing my negative 2. So understand, if this is 5 to the negative x squared, and I've got the dx with that x in the front, well, this x, in order to have my du, needs that negative 2 in front of it. Well, if I put a negative 2 in front here, I need to offset that with a negative 1/2 on the outside. So our u substitution for these is going to work the same way as it did when we were dealing with natural logs. So now, if I try to substitute, I've got negative 1/2 times the integral of 5 to the u du. And now it looks like one of my original formulas. So my answer is going to be 1 over the natural log of 5 times a to the u, which would be 5 to the u, and u is negative x squared, plus c. So here we have one that has 2 transcendental functions within the same problem. Now keep in mind, we are still allowed to separate this into 2 separate problems. That's still the same thing as the integral from 0 to 1 of 5 to the x dx minus the integral from 0 to 1 of 3 to the x dx. There's nothing wrong with doing that. Now I have 2 separate integrals that match what we've got here. So the integral of that is 1 over the natural log of 5 times 5 to the x minus, for this one, 1 over the natural log of 3 times 3 to the x. And we're going from 0 to 1. So I'm going to plug 1 in first. If I plug 1 in for all the variables, I have 1 over the natural log of 5 times 5. So I'm going to go ahead and put the 5 up here. Minus 1 over the natural log of 3 times 3 to the 1, which is 3. That's what I get when I plug in 1. Then I have to subtract from that what I get when I plug in 0. Well, if I plug 0 in here, 5 to the 0 is just 1. So what I get for this part is 1 over the natural log of 5. For this one, when I plug 0 in, 3 to the 0 is 1. So I have minus 1 over natural log of 3. And that's subtracting both of those. So if I have 5 over natural log of 5 minus 1 over natural log of 5, that's 4 over natural log of 5. Here I have negative 3 over natural log of 3 minus negative 1 over natural log of 3. So that's negative 3 plus 1, which is a minus 2 over natural log of 3. If this is a non-calculator part of the test, I would leave it like this. If it's a calculator portion of the test, I'm going to plug it right into my calculator in the beginning and get a decimal without having to do any work. Sometimes you may have functions that have trig in them. For this one, my u part, again, is going to be the exponent. So u is sine x. Du then would be the derivative of that, which is cosine x dx. So I have 2 to the u du. So I've got exactly what I need. 2 to the u du is my formula. So if I use the formula, I will have 1 over natural log of 2 times 2 to the u, and my u was sine x. And don't forget the plus c.